GPT is at what version now? Do you guys know?
4.
So publicly, I think it's 4, but they have 5.4 is what's accessible. Like, so they're way ahead in like research and stuff. They typed in somebody, and I'm sure there's more coding than I'm aware of to this, but they asked GPT 5.4 to answer a like 200-year-old math theorem, like a conjecture that they think is true, but nobody's been able to prove it. How long do you think it took GPT 5.4 to prove this? 1 hour. What, like, it's gone 200 years without being proven. 1 hour is all it took. It's crazy. I don't know if I like that or not. Anyway, we're not GPT, I don't think. Chapter 9. Gosh dang it, second time it's done that. All right. Who is this guy? Just before we... He was a real G. Gauss. Cool. All right. Chapter 9. We're going to start today, and this is awesome. We looked a little bit yesterday at sequences, just briefly. We looked a little bit at adding up sequences, which is not just called a summation. We do the summation, but it's actually called a series. And then the last thing that you will get to see, which is super cool stuff, is the probability part of this. Okay. I will not be here. Obviously, I'm only here for 2 days right now, but let's just see what we can get through. So in 9.1, we are going to begin looking at sequences and series, and we're going to use some nice ones. And I don't want to define it since it's all just right here. I'm not going to write it again. But let's just make sure we can get it out. Yesterday, we didn't write this down, but we wrote and worked out several different sequences. What I want you guys to try to do is thinking back to what we did yesterday, and I'll do it in pink here. Here was a sequence. I don't know if we did this exact one yesterday, but something like it. That's a sequence. Just, we'll agree. What is a sequence? How would you define this? It's a pattern, right? And like, let's make that a little bit mathier. There's a pattern that the same thing happens every time. Would you agree with that? Have we ever seen something else where if I plug in a number, it spits out a different number? It's what makes algebra fun. Chin. That was a weird way. Holy cow, I haven't seen you today. That's weird. It's a function. Whether we just think of it like this, do you think there's a function that spits out that as the first and this is the second and third? So let's just think of them as functions. When you saw them in Algebra 1, you probably said it's just a list of numbers with like a pattern, which you're not wrong. We're just going to say this is a function. A function that produces an ordered list of terms using, and then here's the last little part. I'm gonna let you guys catch up because this part, like, you'll naturally do it, but I want to think it out. Oh wait, I'm trying to ask before you were done writing. In the sequence that I've listed up there, can you tell me what the first term is? 2. What's the third term? What's the 1.4th term? That's a weird question, it seems. Why is that a weird question? It's going to be a weird answer. Talk it out. You're going to be right. I'm sure of it. Talk with your neighbors. Why is it a weird question to me to ask what's the 1.4th term? 30 seconds. Go. Speak. A hard question to answer. I liked what I heard you guys say, and I don't know exactly. I didn't hear it perfectly, but I heard something. What did you say? Like, this is not continuous. We have a first term, a second term. There's no in between. We would never connect these with a line or like a curve if we're drawing them. They're just little dots. It's like a scatter plot is what we're thinking. Now, there might be a function that would fit through them all, but a function is continuous, and we would have those little points in between. These don't. The first, the second, the third, which means I'm only going to use positive integers, which we're going to use this, z plus positive integers, which is 1, 2, 3, 4, 5, like the natural numbers, as input. As inputs. Okay, nothing crazy there. Now, notation-wise, they can be kind of ugly. And the notation's always one of the grosser parts of these, but we're going to work this out. We're going to just get a little bit of notation, and then we're going to jump right into doing some of these problems. Notation. So we'll do a sequence underneath, like as a concrete example, but we normally use the lowercase letter a to represent the terms. So if we were to just write some general sequence here, we could say, oh yeah, my sequence just starts with a sub what do you think? 1. Is it possible that we could start at 0 sometimes? Like, we could, and sometimes we will shift it because maybe it makes sense to start counting from 0 in certain situations. But if we have a1 first, what do you think is the next term? A sub 2, and then a sub 3, and then dot, dot, dot. And if this goes however far, eventually, can we agree we'll get to a sub n? Okay. The subscript here just tells me which integer I'm plugging in. Which term in this list is it? Like a sub 1 is the first term. This is the second term. So forth and so on. Okay. Nothing crazy there, I don't think. Let's write one out. Okay. So example, we are going to list first 5 terms from the following. And I'm going to give us a sequence, but I'm not going to write it as A1, A2, A3. I'm going to propose that we have a singular formula that's going to work with this. So let's check this out. Let's try, I want this. I'm going to give you on a sequence, and I'll scroll down here. We're going to define it as a sub n equals, and I'm going to pause here first, and let's make sure conceptually we're on the same page. This is going to give me the value of which term of my list? The nth term. So conceivably, if I wanted to know the 6th term, I would just plug in a 6 for n, or if I wanted the second, a 2. The formula for this is nothing crazy. It is 2n plus 1. And this is what's known as an explicit formula. I want you guys, starting with a sub 1, just give me, the first 5 terms. It'll take you less than a minute, I think. You're welcome to talk it out with your neighbors. I'll have you do that now. First 5 terms, starting with a sub 1, going through a sub 5. Cool. I don't want to do another one like this, but I do want to sneak in a definition. What we have right here, this formula, it is explicitly telling me how do we get the nth term. And we're going to see the alternative to that, but this is an explicit formula. Okay. If it gives me the 50th term and I don't need to do the first 49, it's explicit. Now, as we go through stuff, there are some nice sequences and there's some cooler, less nice looking sequences. I want to sneak one more in here, and I said we were going to do another one quite like this. We're going to do another one that's a little bit more complicated, but same thing. I want you to generate the first 5 terms of the following. Okay, a sub n, this time, we're going to say is 4, it's a fraction, just so you know, 4 plus the quantity negative 1 to the nth power over n. Before I cut you guys loose, and this will take another minute or so, I'll let you guys get it written, and then I have a question about this first. What does the parentheses around this change about my sequence? Like, there's something really important that happens with negative 1 to certain powers. If it's even, negative 1 to the 2 or to the 4 to the 6 is going to be what? Positive 1. What if it's an odd power? Negative. This is not super formal language. It's hollow language. So I'm going to use purple for this one. This specific piece right here, this negative 1 to the n, I refer to this as a switch. Why? What's it switching? It switches the sign back and forth. So we can have sequences that might go like this one's unique. It's not just adding or just multiplying, but it could go from positive to negative to positive to negative, and it can do that. That's allowed. You would have a switch in it. Give me the first 5 terms of this sequence that has a switch in it. Once you have 5 terms written on your page, I want you to physically stand up, grab your notebook, check with somebody else that's not your immediate neighbor. We need, rather, a nice way to work this out. So I'm debating if I want us to do this as a class or if I just want you guys to try it. We're going to do it as a class because it's going to be harder. Now, if it's an explicit formula, and it's nice. And I got to make sure I'm not going too far ahead because I'm going to spoil it if I am. I am going too far ahead, so I'm very glad I looked. I don't have my notes right now. Okay, let's try a different one. This is an explicit formula. Is this explicit or implicit? We don't even know implicit yet. Is this explicit also? If I wanted to know the 40th term of this list, could you tell me? Do you need to make the first 39? So it's also explicit. These are both explicit. In contrast with that, we're going to sneak in a new one, and this one gets its own little section. Cool. We have another way to define these things. We can use explicit definitions. Those are nice. But from time to time, we have to deal with what is known as a recursive definition. Does anybody recall the word recursive? From Algebra 2 is where I would expect it. Maybe Algebra 1, though. Okay, so if you haven't, that's okay. We're going to define it real quick. A recursive sequence, easy. We'll just say we need first term, and then I'm going to put in parentheses or more, because we might need the first and second, and we'll look at one, to generate the next. Now, we saw an example of this yesterday. We need the first term or more to generate the next term. Now, where these are nice is when it's really hard to come up with a formula, such as one of these explicit ones. But where these fail is on either of these first two examples, if I wanted the 800th term, we can get it, boom, just plug it in. If we do this recursively, to get the 800th term, we need the first 799 of them. So I will never ask you to get 799 terms, just so you know. But let's look at one. Okay. And it's cool because we already talked a little bit about this. So we're just going to jump right in with an example. Example, I want us to find first 5 terms. So same type of example. I don't know why I wrote the word first this time. Weird. Interesting. These switched. 1 and first and 5 and 1. Odd. Huh. No idea. All right. Let's get crazy. You guys are kind of low today, it seems. Yeah. Why? The weather. Okay, let's agree it's the weather. Cool. All right, check it out. On A, we get the following information given. I'm going to write that A sub 1 is 5. All right, and then here's our recursive part. That's just a given value. This next line is truly our recursion, our recursive rule, you could say. We're going to say that if you want A sub k, you just simply take 2 times the previous term, which, what's one term before A sub k? A sub k minus 1. Okay, we're just going to take the previous term and double it, and then add 1. That's it. Now, it looks really ugly, but I assure you it's so much nicer than you think it's going to be. We're going to write more for the first part than you probably will on any other problem doing this. Where do we start? What's the first term? A sub 1 is 5. We were given that, and we have to be given that for recursion, just so you know. If I want A sub 2, and I'm going to be really mathy for a second, this would be twice. What's one term before A sub 2? 1. Or you could simply say it's A sub 2 minus 1 if you want to write that. That's how we get there. Plus 1. Do we know what this term is? 11. Ooh, careful. This term. What's A sub 2 minus 1? A sub 1. It's 5, right? So check it out. It's 2, and then a 5 goes in here, and plus 1 gets us, as Christine said, 11. I just call you Christine? Yes. Weird. There we go. All right. No, okay. Give me the third term, and the fourth, and the fifth. Addison, I get the feeling you might have switched to doing it in your head. And I'm okay with that, like, just so you know. What'd you get next? Once you think you might have this, I want you to check your work on the board. I have the first 5 terms. Let's just see if we agree. And incredibly important, but if you don't agree with it, I don't want you to sit there quietly and just say, oh, I'll figure it out later. Now would be the time to say, I don't get it. Where did you get this value? Okay. So I'm going to step out. I got to go fill up my water cup because I don't know where my bottle is. I heard board is the only thing that I heard somebody say. So we're going to do this one at the board. Okay. Check it out. You guys are finding me for the following sequence. A sub 6. And I'm going to throw you for a loop here. I'm going to change a little bit of stuff. On this one, I'll tell you that A sub 0 is 1. I will tell you that A sub 1 equals 1. And I'll tell you that, sorry, not A sub 2, A sub, and I'm going to change this a little bit just so we can see it works weird. A sub k plus 1 is exactly equal to A sub k plus A sub k minus 1. Oh. Cool. I want you to go find me the 6th term A sub 6. Let me rephrase that. I want you to find me A sub 6. I just, yeah, it's, if I had time to make it, I just don't have time to make it. Just figure it would be like
I think they know
Is A sub 6 just 1?
I didn't start.
A sub k plus 1 equals A k plus
I was like flying.
A sub k plus 1
Yeah.
equals A sub k plus A sub k minus 1.
For a follow-up?
We're
gonna take it.
Ew.
So my advice for the interview process, like the more that you do it,
Well, I'm gonna keep it going.
you should just do it, whether it's with them or not.
I find A sub 7.
You have an interview scheduled.
So, wait, no, 5. Right?
I mean 5. Where'd you get 5 from?
Because it's supposed to be 6.
You mean
Yeah, 5 plus 6. No, A sub 5 plus 1. Because you have to plug in the thing. Why are we supposed to get this?
Why are we supposed to get 6?
Why are we supposed to get 6?
Because we're supposed to find 6.
We could. I don't know, we just try something.
But you're right.
Let's just try. We can look at other boards.
Do you want to write it down?
It would be 1.
Are you going to write it out?
What? Just 1 we can't use 5. There's no 5 from.
So the first term is
To make it equal 6.
A sub 1 is A sub k,
Oh.
and then we need one term before that, so I included A sub 0.
I don't know. I think that's what it is, but I'm not totally sure.
Because A sub k minus
It
1
has to
is
be equal 6. Because if we do that, it's going to be equal to 7.
I'm just trying it.
it's fine.
What? I'm just trying it. I have
Talk about something.
So
We're gonna
this is the same as this. It needs a previous term, so I included A.
If we look at the definition for K before, we said A sub K is something A sub K minus 2. Like, we're shifting stuff here. If we made an underline, I'm just gonna put a couple points on here, and I just want you to put 2 more on based on what we have here, okay? And I know it's weird to think about combine, but I'm gonna say here is A sub K
I was
plus 1.
listening. I'm not doing
What goes here? One step before it. What's
I don't know how to do this either.
Keep going.
What's 1 before this? So if I wanted to get this term, I just take this.
Well, that's group take lines like really differently. They're like
Like that's what that says. To get this term, add 1 before it and then 2 before it. So I like that you have A2
So
here.
we
just keep this because we don't want to erase
That's why I
it.
should erase it. Does that make sense what I was
I
doing?
don't know.
So let's,
I was
like,
just
let's
trying to
just see if
get
we
used
can
to the case.
What's
Wait,
one term?
don't erase that. That's what we need.
Yeah, I'm not erasing it.
Good.
Just erase the bottom one.
This one?
Yeah.
Plus, what's two terms before that? And now you're kicking. Are y'all struggling over here?
Yeah.
Okay, draw me number line. And on that number line, somewhere towards the right side, I want you to put a sub k plus 1.
Like anywhere?
Yep. And I want you to put 1 dash to the left of that. However far, I don't care how far. What's that term?
Wait, so this is the previous.
So careful.
No, 8 sub 1.
You went 1 back, right? That's all we did? 1
So
less
a
than
sub
k
k.
plus a sub k. What's 1 before that one? Do you have a sub k plus 1, a sub k, and a sub k minus 1 on your list? We could write them. Check it out. If I want a sub k plus 1, you put another tick here, and that's a sub k minus 1. And do you guys, does everybody see how we're getting those numbers?
Yeah.
Okay. This rule says if I want this term, I take 1 before it, and I add 2 before it. That's what this is saying. If I want the k plus 1, so let's just put a number. If I want the 7th term, this is 7, this would be 6 and 5.
Oh.
So if I wanted the 2nd term, and let's write it, a sub 2. Notice that this is 1 term behind it and 2 terms behind it. What's 2 terms behind this?
A sub.
A sub 0, so rate equals a sub 0 plus 1 more. What's 1 term behind it?
A sub.
A sub 1
Plus or minus.
plus a sub 1. And we're just using this rule so that if it's a 2, you do that's 1 plus 1.
Yeah.
So here's 1 and here's 0. 1 and 0. They're there. Do we know both those?
Yeah.
So this is 1 and 1. What's 1 plus 1? You're good.
So we just think we don't really look at
Okay,
kind of just like
checking
number
this
right
out. Most groups recognize this, and I got one group still finishing. I even heard somebody recognize my name. This is Fibonacci. Yesterday I used Fibonacci. It doesn't exist. I just use the same rule. I just add a different starting point. Okay, while we're here, do I want to give you another one? Because we need to work it out here. Let's go back to our desks. We'll talk this one out, just make sure we're good, and we're almost done with the section already. So you guys are getting a little goofed up, but we're gonna sort it out. Okay, the whole thing recorded just now, so sorry if you're gonna watch this video. If you are struggling with these, let's just look at this. This is some term, right? This is a term that we're after, the some number. What is this in relation to it? 1 before. And what's this one? Can we say it's 2 before? Okay, so if we do this, and if we can recognize that, all I've done is I just changed. I could start at whatever number I wanted here. I could do a sub k plus 8, and then this would be k plus 7, and this would be k plus 5. Like I just kick down, and I shift it wherever I need. But let's work it out. Do I know the first and the second term? Or the 0th, sorry, do I know a sub 0 and a sub 1? And do you see why I don't want to say first and second term and why it's so misleading? Why I'm going to use the correct language. So let's just work it out. If I wanted a sub 1 and a sub 0 to be written, it's 1 and 1 together, right? And this rule says I do what with, this is my space that I'm trying to find. What's 1 before this? Plus, what's 2 before this? Sorry, what's 1 before this list? 1, and what's 2 before it? 1, and if you add them, bless you. So 1 plus 1 gets me to 2. Now let's add these two to get our new blank spot. 3. Let's add these two. And all I'm doing is it just takes us to be able to see, oh yeah, we just add 1 before it and then the 1 before, like just follow this rule and we can get them easily. Our next term. Next term. And let's see, if this is a sub 0 and 1, 2, 3, 4, 5, 6, there's our a sub 6 term. It's 13. This idea, be prepared for these indices to move around. It doesn't matter. As long as you know what's 1 before a sub 95, you're going to be okay. All right. Well, I'm really excited about this next thing. We are going to talk about factorials. What is that noise about? You think they're hard? Who can tell me what a factorial is and how we write it? I'll tell you, I got louder for a second, but it was on purpose. It's an exclamation point. So we're just going to define it as mathy as we can be. If I wanted to take n factorial, well, Christina, you were excited about it. How does n factorial work?
You take all the numbers from. Do you include 0 or no? Oh, no. Okay, you don't include 0. So from numbers 1 all the way up to n, and you multiply them.
Okay,
So
love it.
plus 2.
I'm going to go the other direction though. I'm going to start at n, and I'm going to start multiplying by 1 less until I get all the way down to 1. What's 1 less than n?
N minus 1.
And what's 1 less than that?
N minus 2.
And then dot, dot, dot. We go for however long this list is until we get to, and this one's going to be ugly. But you'd have to do n minus 1. n minus 1 is where this is going to end. And it's ugly the way that it works out. I'm okay with just leaving the plus dot, dot, dot if you guys would rather do that. I'm cool with it. Okay. Now, these things are awesome. And I will show you in like 10 minutes how you type them into your calculator. But here's the deal. When you're simplifying with factorial stuff, it's not a calculator problem. There's an easy way to do this. Should we do a couple really basic factorials first? Okay. So we'll just build up complexity. And I just want us to find the value. And I'm just going to say find val of, well, let's do some factorials. And then we'll sneak some into our, we'll sneak some into some sequences here in a minute too. Just kind of neat. Okay, so here we go. For our first one, let's get wild. I want us to do, ooh, I'm going to give you a wonky one first. I want you to talk it out. 3 factorial over 4 factorial. Trying to decide if I want you guys to just do this on your own first. You do it your way. We'll meet up in 2 minutes. Not even 2 minutes. We'll meet up in like 60 seconds. Try it out. I want to see what you come up with first. My guess is if I showed all of your work, and I should have, that was my initial intent. I don't think everybody has to multiply all of them, but my guess is you probably did something like this over this. That's literally what it means. Do you guys agree? Without having to do anything else, how could I have made this so much easier? Oh, I love that idea, but we're going to see the same thing happen here. Does anything divide out?
Oh, that's smart.
Hold on. I like your idea. Like, that is smart. I agree with you, but I think there's a better way to write this. Because why would we waste all this time? I want to show you the approach, and I don't really know if it's the best one, but it's the way that I think about them and how I'd encourage you to think about them. Same problem, not changing anything. I'm going to start all the same. It is 3 factorial divided by, and let's think this out. 4 factorial means 4 times what? 4 times 3 times 2 times 1. And I'm just going to circle this one even though I've crossed it out. If only there were a more convenient way to write that. Is this the same thing?
Yeah.
Do I have to expand anything if I do it this way?
No.
What divides out? And what are we left with? We get the same answer in a quarter of the time. Take advantage of this. Just to show you, and I'm going to give you 20 seconds for this one. Okay, 20 seconds. That's all you get. I want 7 factorial divided by 5 factorial. Try to do it the way, not your way. Done for Dolan?
Holy. Probably.
Okay, 20 seconds. If you're comfortable with it, it was probably enough time. If you're not super comfortable with it, it probably wasn't. Check it out. Do 7 factorial and 5 factorial have anything in common? And a weird way to word that is, and this is odd language, so let me know if this doesn't click. Is there a 5 factorial hidden inside of 7 factorial?
Yes.
If we started expanding 7, it's 7 times what? Instead of 5 times 4 times 3 times 2 times 1, what do you think I might write?
5 factorials.
How did I know that I wanted to write 5 factorial? Because I want a 5 factorial to divide out. If you don't like this, and I just want to stress this, can you still do times 5 times 4 times 3 times 2 times 1 and then cross them all out like we did here? It is still going to work. I wouldn't do that. I'm going to cross off the right things. I would do this so it's easier. And then what are we left with? 42. We're done. Work smarter, not harder. You can work harder if you want to. That's also allowed, just so you know. Doable?
Yes.
Okay. I'm going to leave you with a question here, and I want you to move so you talk with somebody else. I want you to come up with an explanation for this. Historically, I've always told people this is true, accept it. I want you to justify this statement for me. And this is not as find the value. I'm just going to sneak it in here. I'm just going to say justify. I'm going to make a claim. Convince me that's true. 0 factorial is 1. Guaranteed. I will tell you if this seems like something you've never seen and never thought about. If you recall me ever talking about exponents and how we make the transition from positive to negatives, a very similar approach will be used here. I'm going to give you guys a moment. Why on earth would 0 factorial be 1? Convince me that's true. I'll tell you, it is true. Everybody agrees with that. What's 2 factorial? 2, and that would have been 2 times 1. Okay, I just want to think this out. If I know what 3 factorial is, how do I go from 3 factorial to 2 factorial? Holy cow, I am certainly writing. I'm sorry. I'm sorry. My bad, guys. Okay, so just to catch us back up. Here's this. How do I go from 3 factorial to 2 factorial? What does it seem I need to do? Divide by this 3, right? What if I want to go from 2 factorial to 1 factorial? I divide by 2. If we divide by 1, it's 1. We can use the exact same logic to build it. This one's a little different because you have to divide by this to get the previous. But we can see that rule happening, I think. Addison, I cannot get a read on your face. Do you see what's happening here, or is it kind of oblivious?
I see what's happening there. It's just, it still seems like it's not true though.
It's weird. I'll tell you guys, it's the first time I've ever explained this. Every other time it's been, it is, accept it, and we just left it there. But that's a better way to do it. Okay, should we do a hard factorial? Okay. Are you sure?
No.
Okay. I'll give you a hard factorial, but we're going to sneak it into something else. We are through with sequences for now. Series. Okay. We're going to define, and I don't like how they make series and summations feel like different things. They are, and we'll clean this up. We're just going to say adding up, and I could say a better word for adding up, if only there was a word that meant add up a bunch of stuff. The sum or the summation, the terms of a sequence. That's all series is. Now, if we just want to add them up, I'm going to remind you, what's that Greek letter that you associate with me and summations? Sigma. And we're actually going to formally write this. So if we want, and we're going to do this big because I'm going to label some stuff, okay? We're going to draw a sigma, which is this big capital E looking thing. And then standard, the index, we use I, but it could be J or K. It doesn't really matter what it is. But we have an index down here that normally we start with I equals 1. And we go to some number. And then we'll just have some sequence defined in here. So I'm going to scroll up just to see one of the sequences that we used today. I'll just use the exact same one. So I'll come right back down. But we had this, excuse me, sorry. 2n plus 1. That's a formula for a sequence, right? Okay. So the only thing that needs to change if we're going to do the series for that one is instead of n, what am I using? An I. And this is why it doesn't matter. This is going to generate the sum of that sequence that we did earlier today. These letters must match. This is our variable. And again, sometimes it'll be I, sometimes it'll be J. Doesn't matter what it is, as long as this letter matches here. Okay, language-wise, this is called my index. It just keeps track of where we're at. The first term, the second term, the third, and we only use those positive integers. This n value, I'm going to do it over here, is my upper bound or my upper limit. It just tells us how far do we go. So we'll start at 1 and we just add up until we get all the way up to the nth term. That's it. Now, this piece, what do you call the inside of a log or the inside of a trig function? The argument. What do you think I'm going to call this of the sum? It's the argument. Like 100%. I'm going to use that same language. It's the argument of our summation. Okay. So I'm going to give you guys a couple because we spoke a little bit about this yesterday. Nobody's looking at this going, I don't think I've ever seen this in my life. Is that true? Does everybody remember seeing this yesterday? All right. So we're going to go up to the boards. And this will probably be the last one we do with the boards. I like the back and forth. You guys' thoughts? Okay. So here we go. You guys are going to find for me a small series. And it's really a partial series is what we'll call it, but we'll clean that up. I'm just going to give you a couple. All right. I want you guys 2 summations on the board. Groups no bigger than 3, just so you guys know. I don't want groups of 4 or 5. I'm going to do the example here. Okay, I want you guys to do the following, and I'm going to pick one person to read this. We'll do I factorial. Cool. You guys go do that summation, and I will get another one up for you guys. Who wants to read it? Okay. Well, the good news is that number 11, I got you. What does this symbol stand for? Not the sigma. I liked your first one. You could say the summation. That's formal, but we're just going to say the sum. From, where do we start, Addison? I equals, and what's our upper limit? How high are we going? 4 of, and then I'm not going to write this in the wordy version. 2 over I factorial is what it is, right? Okay. This is how you say this statement. This is the sum from I equals 1 to 4 of 2 over I factorial. Groups of 3 up on the boards. I want you to find me the sum. I will get part B for you guys as well. Ooh, I'm going to throw you guys for a loop on this one.
We're doing sections. And then watching a movie on Thursday. Because he talked to Amish night and then you convinced him. We're looking for this.
How do I do that?
You can tell us.
Yeah, I just
Oh, okay.
because I want to know.
Okay, what happened?
Cool. A and B